So I want to thank everyone for coming and go ahead and especially thank Than. And I'm gonna go ahead and turn it over to you, Than, and let me know if you need anything.
Okay, thank you very much. So it's really good to be with you all today. Um, One of the things I love about Shepherd Village so much is your sense of place. And that's what I'm going to be talking about tonight. I'm a fisheries biologist with the U.S. Geological Survey at the Eastern Ecological Science Center. You probably know it by the former name, Leetown Science Center. It's down the road. What I'm going to be talking about is the natural history of our place from the river's perspective, okay? And I know that this has really shaped my worldview about where I live and the context in which I live in. It's enriched my perspective of this place, and I hope it'll enrich your perspective of this place too. I do have a couple of slides I wanted to show, and I really, would rather avoid the death by PowerPoint option. So I know I can get kind of technical and get into a lot of specifics, and I'm going to try to give you a little bit of a taste of different things, and then reserve time for discussion because, I am an expert in some things. I am an expert in river and stream ecology. I'm an expert in fish biology. I'm an expert in water quality, but I'm not an expert in all things, and you guys are. And so I think this is a two-way street here. I want to be picking your brains right after I let my dog in. Just 1 second. Hey, this is the real world. You guys know how it goes at Zoom, right?
And Than, do you want people to interject questions throughout or wait till the end?
Either would be fine by me. I've got a couple of slides queued up here. I would say throw them out. It's informal. Of course, it's informal. But I wanted to seed some thoughts, right? And as we go through this, there'll probably be some things that'll be catching your eye. And I want to have time for this. So what are we thinking about? 45 minutes here, roughly speaking?
Yeah.
Okay, so let me do this. And I'm going to move through these slides. Feel free to ask questions. I'm going to give you some big picture ideas. Okay, so let me do a screen share and I'll start this. Can you all see this?
Yes.
Okay. And let me move this guy down. So, is that coming through?
It's perfect.
Okay, great. So, many of you are familiar with Aldo Leopold. This is one of the most important books in my life. This is probably one of the most important books I've read. And Aldo Leopold, makes the point that an ecological education has a cost. I mean, it basically seems that we live in a world of wounds. That is true. But I would offer this as a counterpoint. Ecology also gives us a sense of our place in the world. And this is so important. It gives us a sense of our deep connection to space and time. And moreover, this is especially true for rivers, okay? Rivers. And that's the focus of what we're going to be talking about today. The Potomac River. This is our backyard. This is our home. So let's learn about it. There are a couple of things I wanted to touch on. First, like the big picture, why rivers and fish biology? Why do I think this is fascinating and worth our time? I'll dig into a deep timeline of the Potomac River, a deep timeline of our place here, give you 3 specific fish stories based on my research, and I'll give you a little vignette of each one. And then I want to wrap it up with some concluding thoughts and then get your feedback and have some time for discussion. This is kind of my website. You can read about my background here. I'm at the Eastern Ecological Science Center. I do climate change work. I do fish population dynamics. I do a lot of statistical modeling and forecasting. I also do a lot of field work where I'm out there sampling and doing some new work in our region. So I really feel blessed to have this opportunity. The scope of the things that I'm dealing with involve population dynamics, and how species interact, and land use and climate change in particular. And I'm also now working on, conservation planning, restoration planning. So this is ecology, but it's applied ecology. It's hopefully relevant for the purpose of conservation. I run an experimental stream lab here. This is a picture of some of our tanks or pools and riffles that are connected. We've had to curtail some of this work with COVID, et cetera, but we've done some, I think, pretty innovative experimental work here at the the Eastern Ecological Science Center down in Kearneysville. But the focus of our time today is on the Potomac, okay? This is our backyard. Many of you, of course, know this map. This is the watershed of the Potomac River. We're in the Chesapeake Bay watershed, of course. The Potomac River has a lot of unique features to it. One of the most unique things about the Potomac River is that it cuts through several different, ecological regions, okay? We can call these the plateau, Appalachian Plateau to the west, the Ridge and Valley, Great Valley, the Blue Ridge, of course, the Blue Ridge we know and love from Shenandoah National Park, Catoctin Mountain Park in Maryland, and then into the Piedmont and Coastal Plain. And this is the geography of the landscape that affects the biology of what we see in the rivers and streams. And it also has a big effect on how humans have lived here and survived here. Of course, we know Great Falls of the Potomac. This is an important feature of the Potomac River near Washington, D.C. Great Falls is a natural feature. It's also a natural fish passage barrier, and that has had some very interesting effects over the course of millennia, in the context of our backyard, and I'll get into that. So we know, the Potomac River is special. The Potomac River also, of course, is the drinking water supply, not just for Shepherdstown, but also for Washington, D.C. It's very important. So when we think about rivers and how we understand rivers, I think an important starting point is that we often treat them as the edge, right? We treat them as the boundary. We treat them as the end of something. And that does make some sense. I mean, when you think about, the history of can you get across something, the rivers are kind of an edge. But truthfully, they're the center, right? They're the ecological, biological center. All water drains to these major rivers, but we treat them as the edge. And we can see that clearly when we think about which of our state lines are really artifacts. We should be working across these state lines, but yet, because they are the environmental true center, but we treat them as the edge. And that has implications. It has implications for the way we operate in the Clean Water Act, the Endangered Species Act. The list goes on and on. How we regulate water supply, how we secure our water supply, these precious resources. My point is that the rivers are the center. We often treat them as the edge, and we can see that here in this map. This also has implications for the way we think about conflict. A recent paper came out in Science here, and so basically they call this sort of euphemistically the likelihood of hydropolitical interaction. What they're talking about here is water wars, okay? They're talking about military conflict or social unrest in the context of diminishing water supplies and conflicts over those water supplies. This is something we have to understand. And I'll highlight one area here. It's sort of browner areas or higher likelihood of conflicts. This is the upper Cairo watershed, which flows through Egypt. If Ethiopia dams this river, as they are planning to do, we are in for a major conflict. And that's just one example of many and many. So let's just take a moment to zoom out. I'm not sure if this comes through with this bar on the top here, but if we think about the entire the life cycle of the Earth in a 24-hour clock, humans have been around for a second and a half, okay? So humans have been around for barely no time. Fish, however, our first vertebrates, have been around since about 9 o'clock on this, in this perspective. I think that's important. So if humans get 2 seconds out of this 24-hour clock, fish get several hours. They're still kind of new, I guess, in the context of 4.6 billion years of life or of the Earth, but there are ancient ancestors. And as I think folks at Shepherd Village in particular will recognize, that it's a good practice to respect your elders, okay? So we can think about this in a couple of different ways. If we represent sort of the evolution of life here, this is kind of represented as a spiral. 4.6 billion years ago, we have the oldest rocks on Earth. The first fishes showed up about 500 million years ago in the Cambrian period. These are the oldest vertebrates, okay? The Appalachian Mountains, amazingly, this blows my mind. The Appalachian Mountains were actually very recent on the scene after this first vertebrate. 360 million years ago, the Appalachian Mountains, where we live, is one of the most ancient mountain ranges on Earth, okay? One of the most ancient mountain ranges on Earth. For example, it was millions of years after the Appalachians formed that we saw the evolution of birds. So contemplate that for a moment. The mountains were here millions of years before there were birds to fly through the mountains, but there were fish here, okay? And that's something to consider when we think about the deep evolutionary history of our place. Another thing I'm going to point out here, and I hope this is visible, it's not, I got a little bar here, but this is something I'm going to touch on later. The limestone deposits, the rocks that we find in this place under the Potomac River, that has a lot of important implications for climate change in our place, those were laid down here about 300 million years ago. So you can go out behind Shepherd Village right now, look at those limestone bluffs that are around the region. You can see limestone come up. You touch that rock, you were touching a rock that is 300 million years ago, that was laid down 300 million years ago. It was essentially the shell material of ancient oceans that was deposited and laid down. You touch that piece of limestone, you're touching a piece of rock that was laid down by an ancient ocean that was there millions of years before there were even birds or flowering plants on the landscape. But there were fish, okay? So let's kind of zoom forward here through time, and let's think a little more about the Potomac specifically. And this is still a long time, right? I mean, this is my point is that our perspective of time, it gets blown apart when we think about deep evolutionary history of biology and fish in particular. So 10 to 20 million years ago was when we saw the oceans, the shallow oceans over much of the Chesapeake Bay retreat, okay? And around 2 to 3 million years ago, we saw the glaciation, obviously through this period of time, there's been many glaciation events and many other extinction events and all sorts of stuff has happened. The Earth is dynamic. But it was this glaciation event about 2 to 3 million years ago where all that water was sucked up into glaciers on the poles and the sea levels dropped. And the oceans were about 100 miles out to the east from where they are. And so what we see now is the Chesapeake Bay and the rivers that flow out to the Chesapeake Bay, those extended another 100 miles at least. So there were these super networks of rivers, right? And that's, by the way, how fish migrated up the Atlantic coast, because this was all one watershed before the oceans rose back up again after the retreat of this last major round of glaciation. However, as I said, this comes in waves, and there have been more recent glaciation events. The most recent that's relevant for us was about 35,000 years ago, ended about 15,000 years ago. It was called the Wisconsin Age Glacier, and this put a glacier into Ohio and Pennsylvania. Now, importantly, this did not cover the Potomac, right? This was a glacier that was limited to Ohio and Pennsylvania. It's a huge chunk of ice, and it refrigerated the air temperature. Air temperature was much colder, and the water temperature was much colder, but it didn't scrub down the landscape like glaciers often do, okay? Now, on top of all of that, the first humans, where did the first humans? 12,000 years ago. The first humans, 12,000 years ago. And of course, that's much preceding the European colonization. We're obviously very new on the scene here. I want to make the other point that, when we think about our connection to things, we are from fish. Let's face it. Here's the first, if you can see my cursor, here's the first vertebrate. Okay, which was actually a jawless fish. Think about the lampreys or the hagfishes, jawless fish. So they've actually persisted through time. You still see in the present day lampreys and other ancient species, but then you see the emergence of new forms, the cartilaginous fishes, the sharks, et cetera, et cetera. And then you see this group, the mammals. And guess what? This means you. All right. Um, Another point that I want to make here is that as the Appalachian Mountains were pushed up through essentially the convergence of North America and Africa through a great collision, okay, and I'm pretty sure they did not have a permit from Maryland Department of Environment for this. They crushed together, and as that caused a global change such that some species went extinct, entire groups of fish species went extinct. The placoderms, the armored fishes, they're done. And so you think about this deep evolutionary history, and it gives us a respect for the fact that we can even make it through all of this. Now, let's turn to the more recent piece, the human piece. Native Americans have been here for a lot longer than European colonists, and we can see evidence of this right now. I don't know if folks have seen this, but I will encourage you to go to Google Earth and check this out. You'll see what I'm showing you. So we see Shepherdstown here on the map. But if you look north from Shepherdstown towards NCTC, for folks are, I'm sure, familiar with that, and then zoom in, there's an island called Shepherd Island there, go into that, and you will see this feature. This is a fish weir. This is a weir that was constructed by Native Americans here thousands of years ago, and it still remains observable today. This is amazing. These are large boulders that were put in the river to make a V, and that V was supported with small stems like pawpaw trees to create a sort of basket effect where fish would be caught at the outlet, at the downstream V point. So this river has supported people. It has supported people for many thousands of years. We also can see some of this is a reconstruction of what's thought to be the original sort of housing. Massawomack tribes, the Potomac tribes, of course, these are all part of that Algonquin nation, the larger nation. And here's a look at a reconstructed sort of fish weir, a fish basket that was used in these weirs. And this is part of our history here in the Potomac too. We have to really respect this. Now, I'm going to turn to a couple of fish stories. Okay, I'm going to tell you 3 fish stories. And the first one is about the American eel. American eel. This is a native fish that's been here forever. This is a fish that has a very interesting history to it. It's a fish that spawns out in the ocean, okay? And it's basically in the Caribbean. You can see here on this map, the Sargasso Sea. This is where this fish spawns, so the eggs hatch out there, the larvae get swept up by the Gulf Stream. By the way, if we lose the Gulf Stream, which is a very real possibility in the context of warming sea temperatures and the changing salinity of ocean water, well, this shuts down. One consequence is that Europe is going to freeze. All right, that's not good. The other consequence is that American eel will go down. Because they ride the current and they get swept up into the bays along the Atlantic coast, including the Chesapeake Bay. This is what we call catadromous. So you've probably heard of anadromous. Anadromous would be the salmon and trout that migrate into freshwater to spawn. This is the opposite. This is catadromous, where they migrate out to the ocean to spawn. But the point is that it connects us to these places. It connects huge distances. In fact, it's interesting that what happens really is that when these little juveniles find themselves in the Chesapeake Bay, once again, all the females do all the work. All right, so the males, this is always dangerous when you start anthropomorphizing, but the males will stay down in the Chesapeake Bay and they will mature there. The females go up into the mountains. They go up into the Potomac River. They go up into Opequon Creek and to Town Run and to our little tributaries here in the region. And they can spend 20 years there. They can spend 20 years there. And when it is a dark, when there's a new moon, so there's no light and it rains, that's the signal. They out-migrate and they go back to the ocean and they spawn and the cycle continues. I think that's amazing. They also, by the way, can get up Great Falls. I mean, just try doing that yourself. So I think this is a fascinating story about how we're connected in huge places. I've done a little research on this. We were looking at dam removal. I didn't have the privilege of pushing the plunger on this. The Army Corps of Engineers did, but this is the Embry Dam on the Rappahannock River, one of the rivers that comes up from the Chesapeake Bay. And this was thought to be a big barrier for anadromous shad and herring, right? This is what we think about as the founding fish for the nation. It's clearly important for our nation's history. But there was also, it was thought that this was really important for the immediate area. Like we're going to blow out a dam, we're going to allow fish to migrate, we can improve fisheries in that local area. And my research group kind of thought bigger about this. We wanted to think about what's the relationship of that dam removal all the way up in the mountains? Is there an effect are we connected to the downstream river in the mountains where we live? And we looked at this particularly from the perspective of American eel. We did some modeling and simulation work, and each one of these little line plots represents the abundance of American eel, the average abundance through a bunch of surveys. And the vertical line there shows when the dam was taken out. Now we're looking at, these are eel abundances in the mountains, okay? And then we forecasted, so like what would happen, what would we expect if the dam was still there? Like if the past predicted the future, what would we predict? What's the range of variation? And we can see that the observed abundances right here, the observed abundance in every case is much higher than the sort of expected abundance if the dam was still there. So this is really, I think, powerful evidence that the dam removal and the connectivity of these rivers matters, not just for the local place, the 100 meters around the dam, but it matters in this case for 150 kilometers upstream. We are connected to the ocean through this species. We published this paper a couple years ago, and it was actually pretty cool. They recognized this as the paper of the year for the American Fisheries Society. Second story, I'm going to shift gears. And I know that I'm blasting a bunch of stuff at you, and I hope you just put a pin in that. If there's something you want to talk about, put a pin in that, and then we'll have time to unpack this stuff. Second story is about smallmouth bass. And smallmouth bass is a non-native species. It was introduced in the Potomac River in 1854, introduced from the Ohio River Basin, in the Ohio River Basin where it is native. And so those were brought over in a rail car and released into the river, and they've expanded from there. But I want to highlight this species because it's an extremely important cultural connection to the river. This is the most popular sport fishery on the Potomac. There's no doubt about it. It's hundreds of millions of dollars in annual revenue to the Chesapeake Bay states, but it's vulnerable. Okay, it's vulnerable, and in fact, the work we've done here is trying to understand that from a climate change perspective. So, I want to give you a very brief context of this, and I promise I'll try to be very, very brief about this, but I think it's important to get some idea about why, or about how we approach this question of is smallmouth bass susceptible to effects of climate change? I mean, what do we expect from climate change? We expect increasing extreme weather events, increasing droughts, increasing floods, increasing water temperature. So how do we think about it coherently? And our approach to this was to develop this, or to apply this concept called life history theory. And this is where we can think about how different species, such as American shad and catfish, and for example, banded killifish, all have different strategies for survival. The main idea is that species down here in the bottom right-hand corner, these are the ones that require a stable and predictable environmental condition, okay? They're investing very much like humans, by the way. They're investing in parental care. They have few eggs, but they're large eggs, and they make sure that that each of those eggs survives. They invest in that. Now, the challenge here is that it's exactly that feature that may be challenged by climate change, okay? Other species, the opportunistic species, for example, will have thousands and thousands of eggs and invest no parental care. And if one cohort gets wiped out, they can have another instantly. That's not the case for species that invest in parental care, much like mammals, okay? Much like mammals. So we looked at this through a number of sites. I worked with Maryland DNR. This is a fantastic data set. I had the privilege of doing some of the statistical work for their program. These are a number of sites. You know, we can recognize these all the way down from Paw Paw all the way down to Seneca on the Potomac River. Every year they go out and sample fish and they do all the species work, and they handed me this gigantic data set that I could do something with. And they've been doing this work since 1972. We had the first paper that was published from it. So I'm happy to be able to use it for something relevant, I hope. So we basically developed some models of, are the species increasing or are they decreasing over time? And so basically you see all the scientific names here of all the species. The one in red, Micropterus dolomieu, that's smallmouth bass. And the little black circle indicates the average, is it increasing or decreasing? And those gray bars give you an index of confidence, like how confident are we this is a true decrease or a true increase? And for smallmouth bass, we're highly confident this is a decrease. So it is decreasing over time. Now, the question then is why? What's going on in the river? The Potomac River is actually in quite good shape. The Potomac River is largely unregulated, okay? There are not many reservoirs or storage dams on it. Of course, we know dam number 4 upstream from Shepherdstown. There does not a lot of storage in that. So as big water comes in, big water goes out. There are Stonewall Jackson Reservoir. There are a few relatively small impoundments, but largely the Potomac River is a natural flowing river. And in fact, it's one of the most natural flow regimes of any river of its size in North America. So that's something that gives us something. It's very natural in that context. We can talk about the contaminants issues later, but in terms of the flow regime, it's in quite good shape, and that gives rise to unique habitats. But it also makes us susceptible to the effects of a changing climate that drive their flow regime. Okay, because what happened in the past, even for millions of years, may not predict what's going to happen in the future. And I think that's something we have to take seriously. So for example, we can look at the time series plot for smallmouth bass, the colors here, so we can see, time on the x-axis here from left to right, and we can see basically the abundance from bottom to top on the y-axis. The red lines indicate the downstream sites, the blue lines indicate the upstream sites, and you can see one thing is these are highly, you'd say synchronous. They all change together, right? If the abundance in Seneca is high, the abundance in the upstream sites will be high too, which is interesting because what that means is that it's environmentally determined. Okay, it's environmentally determined. So we've explored this in a recent paper, and I won't go into details. We can talk about this more if you'd like, but we explored this and concluded that it was flow variation, it was flooding, it was increasing unpredictability of flows. That is a climate change signal. Moreover, we've done this work for another species of extreme importance in our region here, as well as across the Appalachians, native brook trout. As my mother-in-law Marie knows from the Smokies, brook trout is a huge focus in the Smokies. It's also a huge focus in our region here. West Virginia DNR is actively trying to restore brook trout, but here's the point, that as flooding increases, brook trout populations decrease. What I'm showing you in this plot here is a series of simulations. So if you can see the top left, high precipitation, if you get flooding every 5 years, it doesn't matter. You'll have stable populations. They'll keep carrying on. And that's the way nature is. Nature is adapted to catastrophe as long as it's not every year. Okay, this is a point I want to come back to. Because when you simulate the scenario of a high winter flood, or in other words, flooding every year, these populations decrease and they go from living to dead. So this is something to watch. Extreme weather, flooding. Clearly, there are infrastructure concerns there, but there are also fisheries and wildlife concerns and water security concerns too. The third story I want to tell you is about a new species. And this one, I think, has not gotten nearly the amount of attention that it should. This is the checkered sculpin. Okay, I should say, formally, this is an undescribed species. I'm collaborating with a team right now to formally describe the species, but it's widely recognized by all the ichthyologists that work in this region. It's been widely recognized for many, many years. I mean, the species description paper, truthfully, should have been written 20 years ago, but the second best time is now. Okay, so that's what we're doing. And here's the key point that we should be thinking about. This species only exists in our neck of the woods, okay? The global distribution for this species is what's called the Ridge and Valley section, the Shenandoah Valley, within the Potomac River basin, okay? That's one point. And the other is that it only occurs in the last cold places, okay? This species is a climate change indicator. It is limited now to the last cold places. And here's what it looks like. So here we are, the global distribution, this is it for this species. Limited. In fact, that's even an overestimate. What we need to think about is how it's really not, it's very patchy. It's isolated population. So there's places like Bullskin Run, there's a little population there. Antietam Creek, a little population there, but they're not connected. The river is too warm for these species to move in between. So they're isolated now. This is an important one. I actually got a call from some reporters recently following up on this and expect to see more about this because I think it is a huge story for our region and it's a story that has not been told. Okay, so we're working on it. We did some work on this. We had a paper come out last year fleshing out some of the uniqueness of this species. And we're actually working on a study right now that attempts to understand this from the perspective of what I mentioned earlier, the limestone. The limestone in this region and the dolostone, basically they're carbonate bedrock. And what this ends up doing is creating caves, okay? It also creates fractured rock layers that water moves in very quickly and out of often very quickly. The size of those aquifers is the key part. And this is what we're trying to resolve in an ongoing study. We have a number of sample sites you see out here. An ongoing study, including streams all across the Eastern Panhandle, Town Run here. We have a site actually at Morgan's Grove Park. I mean, so this is kind of fun. We're bringing this regional and global thinking home to our place where we care about. The other thing I'll mention here quickly is that this research has implications for how we think about water quality. And I know that in Jefferson County, the concern over industrial development and water pollution is very, it's elevated. It's an elevated concern because there are elevated risks. So we need to understand how secure these groundwater aquifers really are because look, there's a cup and there are many straws in it and we're all drinking from the same cup, okay? That's what the groundwater is. We need to understand how big that cup is. Where does it go? What's coming into the cup? Because we're all drinking from it. Okay. And this is ongoing work. I'd be happy to talk about this more if you're interested. Another quick look ahead. Again, just a teaser for stuff that we're doing. This is a picture of the back of another species of sculpin in our region. It's called the Blue Ridge sculpin. This is also endemic, globally limited. Only place it occurs on the planet is within the Potomac River Basin, but it's not just limited to the Ridge and Valley province. It's more broadly distributed. In any case, what we know is that it's been extirpated from a stream in Catoctin Mountain Park. Maybe folks are familiar with that in Maryland. Beautiful place. Also has some blue ribbon trout fishing. And this is an important part of that ecosystem, the Blue Ridge sculpin. We did some experimental work to see if restoration was possible. We believe that it is, and we have a project starting this year to actively restore this species to its place and to monitor the success of that over time. So just to wrap it up here, and then get into a conversation. I think it's, for me at least, it's very true that I feel that my perspective of my deep connection to the earth has been enriched by the research that I'm doing and the natural history, but the connection to deep space and time is illustrated through these rivers. And so I really feel blessed to be able to dedicate uh, my career to understanding these things and to making them relevant, hopefully, for people that are putting to use for conservation and management and planning. And that's what I'm happy to do. So I'd like to now I'll start picking your brains. I've thrown a lot of concepts at you, and I've blasted through years of research in a couple of minutes, but I would like to turn it over for questions and get a discussion going. I'm going to stop the screen sharing now, and then we will just go from there.
Great. Well, thank you for a very interesting presentation. You mentioned, I think it was number 2, about the Potomac. It wasn't necessarily water quality you're talking about, but the way it flows is one of the more natural, or what?
Yeah.
Why is that? What?
Well,
Whoops, you got muted.
yeah, it's because we don't have the dams. We don't have the storage. If you go west to the Ohio River and look at a map of the storage and all the reservoirs, we just don't have that. So in fact, the river is quite natural in terms of its flow regime, which, as I said before, is a good thing, but it puts us sort of at risk. I mean, for one, I would not build a house on the floodplain of Potomac right now. I wouldn't recommend anyone do that. The Potomac will be getting more extreme floods and droughts.
Phil asked, what's the water quality history of the Potomac River?
Yeah. It's a long history there, and there's a lot of work that's going on in Potomac, particularly in the context of the what President Obama initiated for the Bay Act, which regulates nutrients, it regulates contaminants, and people are still trying to live up to those goals. States are really doing the collaborative work there to live up to those goals. The main concern that I have about water quality on the Potomac is the PCBs, the organochlorines, the stuff that is really sticky, the stuff, I mean, sticky from a biological sense, the stuff that gets into food webs and doesn't let go. It's also in the sediments. So, I would not advise, I don't have any formal guidance on fish consumption advisories, but you'll see that states put out fish consumption advisories that advise against fish that are on the bottom of the river. They're in contact with PCBs, and the fish tissue shows it. I think one good way to look at the world, it's strange, I do this kind of everywhere I go. I ask, can you take a cup of the stream? Can you go and drink from the stream? You should. Can you? And the answer is no, everywhere you go, with the exception of the very top of dolly sods, some high quality springs, and the middle of the boundary waters. Folks are familiar with the boundary waters on the Canadian border. That's fresh water that I trust to drink, as it is. Drinking the Potomac River, we should talk about that real quickly. Where do towns get their water supply? Shepherdstown proper does source their drinking water from the Potomac River. The backup supply is town run. So organizations like the Interstate Commission on the Potomac River Basin, they and the U.S. Geological Survey have developed kind of emergency alert systems. So if a spill comes down, we notify the water managers. Shepherdstown turns off the valves from the river and they turn on the valve to town run. Town run, of course, people think that it's by the train tracks, it's roads crossing over it, doesn't matter. I would just say we need it. Town Run is our backup drinking water supply. And this situation gets even more extreme in Harper's Ferry. Elks Run is the tributary that is the primary drinking water supply for the town of Harper's Ferry. Elks Run is also connected to the groundwater through Jefferson County, because we know this through dye testing work that's been conducted by the USGS over years. So we know that, for example, sinkholes in the center or the southern part near sort of Ranson area of Jefferson County show up in Elks Run. Dye from those sinkholes also shows up in Rocky Marsh Run towards the north part of Jefferson County. And so we're connected, you know. Honestly, the unanswered question there, and the more complicated question, is related to well depths. If you have a lot of, you know, the majority of folks actually in Jefferson County are on wells, not municipal supplies. So those wells could be at variable depths, and it's possible that those wells are much deeper than this surface aquifer we're talking about. But that's an open question, and that's one that I look to the expertise of you know, the geologists that I collaborate with. And another cool thing about you know, the work that I get to do is that, you know, I'm a biologist. I think about life and the history of life, but I get to collaborate with people that do the physics, the geology, the hydrology, and we try to build teams that can be integrated. I mean, you know, it's easy to say, it's hard to do, but that's what we need to do, because I think everyone recognizes ecology is about the connections. You have to think, it's all about the connections. And so to be connected, you have to think about collaboration and integration. So you have to be, you have to be thinking in a multidisciplinary way, which is complicated, which is messy, but which is really interesting.
So Phil asks a follow-up: is the Potomac River quality trending better or worse, and why?
Yeah, so some indices are looking good, some indices are not looking good. Yeah, the indices on, so some trends are good, some trends are less than good or bad. The nutrient trends are looking pretty good. We've seen reductions in phosphorus and nitrogen through helping farmers do, you know, the work of the Clean Water Act is relevant, and we've seen real improvements. You know, there's the famous story about the Cuyahoga River in 1972 catching on fire. One of the motivators for the Clean Water Act. We're a long way from there. So the trends on the Potomac are good in that regard, but I'll tell you where they're bad. It's on water temperature. And we see increases in water temperature right now that are substantive. And this is a concern. And it's also extremely, I think, interesting and important because we're a natural river here. To see a natural river change, well, we can't chalk this up to a reservoir release or some sort of effect like, no. It's atmospheric. It's atmospheric drivers. And we're highly confident about that, by the way. There's been all sorts of work done there. One piece of a trend that I think is interesting and hasn't gotten enough attention is on the pH trends. So pH, you know, measure of acid and base. So I mentioned limestone, and this is one of the really cool things, you know, we need to think about from our region and how we affect the larger area, the Chesapeake Bay. So limestone is based on calcium. And there's dolostone, which is based on magnesium, but it's basically the same thing. And what you see is that as acid rain, so rain is slightly acid always, and that carbonic acid basically melts the calcium and shoots it downstream. When the calcium gets downstream, it's expressed as a base. So basically what happens is, so people think about acid rain, and this was, you know, obviously a problem that's not been fully solved, been a big problem in the 90s, and in particular, my father-in-law was a big pioneer in working on acid rain. And by no means is that sort of a problem solved, but we can say that there are, now interestingly, the effect that we see in the Potomac, and not only that, but all along the rivers of the eastern US, all along those rivers, we see that things are becoming more alkaline, or in other words, more basic. We're going away from acidity and we're going towards alkalinity. Well, that's interesting. and in fact, there are sort of toxicological concerns. So one of the things that alkalinity does, especially in the context of high temperature, is that it makes things that are not toxic more toxic, okay? And particularly nitrogen. So nitrogen exists as different forms. Nitrogen grows plants, nitrogen is good, but too much, of course, like anything, is bad. And what ends up happening is a not toxic form of nitrogen becomes a toxic form for fish and wildlife when it is warmer and when there's more alkalinity. So this is kind of a toxic convergence. And people aren't talking about this one yet. I've been communicating with the University of Maryland and all over to try to raise some awareness about this. And there's a lot more work to do there. I don't want to be alarmist, but I do want to say that is one to pay attention to for sure.
Okay.
Was another follow-up on that?
Yeah, we've got a few other questions. I guess I'll just keep reading them. I mean, I don't mind if people want to unmute and read them themselves, but if this is working for y'all. Charlotte asked, what do you know about possible effects of Rockwell on the water quality here?
Rockwell. So I know that we're vulnerable to contamination. And I know that from USGS's dye testing work. This is some of the best evidence we have of understanding where water moves, okay? But I want to talk about what we're certain about, and then I want to talk about what we're uncertain about. On the certainty side, we know that water moves from south to north in Jefferson County, very near the Rockwell facility, and a sinkhole, basically Shenandoah area. You put dye into that sinkhole, it comes out in Elks Run, the drinking water supply to Harper's Ferry. It comes out in Rocky Marsh Run. It comes out in tributaries throughout the county, primarily to the north and east, but we're connected. We're highly certain about that. We're also highly certain that there are sinkholes on the facility's property. Okay, and in West Virginia, DEP has documented this. So to me, what that means is that there's a risk. What we're not certain about is this. Now, the dye testing is very good to see where the surface layer of water goes. And there's some mixing there, but many of our wells are much deeper. Some are not, some are less deep. And those are the ones I'd really be concerned about. So what I'm encouraging people to do right now is to understand how deep your well is. The deeper, the better. And we need to do more research to understand what depths are at risk. So I would say that's the side where I am less certain. But in terms of the risk for contamination, I'm highly certain there's a risk for contamination there. As a biologist, I have a small. I acknowledge I have a limited window into the world of the hydrology and geophysics that is at stake here. But I think it's a great question, Charlotte, and I just think it's important for people to realize that not only Rockwell, but whatever happens on the landscape, we are all basically drinking from the same cup, where we are all connected through our water.
Okay, we have a question from Izzy. No, I think it's Kay. Kay typed it. What about the forever chemicals that we have heard about in Antietam Creek?
Okay, so the jargon for that is PFAS, PFAS, and that's one of many. I get to work with Vicki Blazer, Dr. Vicki Blazer at the Eastern Ecological Science Center, who really is one of the pioneers on fish health, and some of her work has shown that there are species of contaminants that are very you'd say sticky, or that they don't flush out of systems. They remain in those systems, partly because of sediment binding, partly because of biological binding. So Antietam Creek is important because it's essentially the drainage for Hagerstown. And the interesting thing about Antietam Creek is also that it may be buffered by, well, it certainly is buffered by some of the limestone we have there. I mean, limestone is maybe one of the reasons that's going to keep our region, our water quality and our water supply intact, because all of that calcium has beneficial effects on binding contaminants, on providing stable flows, on keeping temperatures cold. As you increase temperature, one of the things we've found repeatedly is that toxicity becomes worse at higher temperatures. So there's an interaction between, climate change thermally and contamination. So to answer your question, is like, I don't know exactly what what Vicki is up to these days on her work in Antietam Creek. I do know that she's identified some persistent contaminants that have probably emerged from the Hagerstown source, and those are industrial sources. So I'd point you to her for the real skinny on that. But of course, PFAS in the news recently has been a huge issue for human health and contamination on the Ohio River. So in West Virginia, Parkersburg area, Huntington, the western side, where industrial development there has been, a source of persistent contaminants. That's a real problem. I would say that we have some experience with this. I mean, PCBs in the Potomac River are a legacy, and that's just a nice way of saying we really screwed up the river, and we don't know how to clean it up. But that's a legacy, and it's true. So PCBs in the Potomac mainstem has been a chronic problem for years. Antietam Creek is now seeing sort of what Potomac River mainstem has known for years in terms of its contaminants. But once again, I want to highlight that the Potomac River actually is in quite good shape. I mean, yes, there are contaminant problems. I'm not going to go to the Potomac tomorrow and scoop up a glass of water and just drink it. But I think we really are lucky, and we really need to appreciate how intact it really is. If you go to any other river of its size, the James, the Roanoke, Rappahannock, you go down the Atlantic coast, any river of its size is going to be channelized. It'll be more fragmented. It'll be more contaminated. And that's something that we should not take for granted here.
Okay. Gail asked about the little checkered sculpin that you showed, the species. Do you get to give it a scientific name in the species description paper?
Yeah, we do. And I'm deferring to my colleague at Frostburg State University, who has really done the pioneering work on this, Richard Racely, biology professor at Frostburg. And the scientific name will be Cottus. So Cottus is the genus. The species name will be Robinsi. It's an honorific to one of the first fisheries biologists, Robbins, who worked in this region years and years ago, and that's an honorific to the original work. And I hope this is going to make people pay attention to our region in a different way. This is a vertebrate that has not been described, which is a big deal. Okay, it's also a climate change indicator, which has not been really well understood. And what I'm saying is that we are living in a place that vertebrate species are imminently, connected to climate change and are experience risks from climate change. And the reason I can say that is that we know that the distribution of checkered sculpin is only in the last cold places right now. As I mentioned before, so we zoom back through time, right? So 12,000 years ago, the Wisconsin Age Glacier was melting and kind of air temperature was coming back up 12,000 years ago. But it was only a few thousand years ago that we had what was called a mini ice age. And this really affected the Native American agricultural development. So for example, the Upper Potomac River was never really it wasn't farmed per se by Native American tribes, at least according to the scholars that I've read. it wasn't farm, but the Upper Potomac was a seasonal hunting environment. It was a fishing environment. There's fish weirs, for example, but there was not large scale agriculture. In contrast, in the Potomac, downstream on the Potomac, in the coastal plain near current day DC, Native Americans had set up large scale industrial agriculture. Okay, and that's because it's a lower elevation, so it's warmer, right? Higher up you go, the colder it gets, mountains, etc. So only a few thousand years ago, the air was much colder, and that prevented industrial or large-scale agriculture of corn, which was developed here, used here. It was limited to the coastal plain. I think that's fascinating. I mean, you can see artifacts of the fish weirs here. There are also middens of fish that were harvested. One of those I should mention is fall fish, a native fall fish. Anglers may be familiar with this. We don't have to just look to introduce species for sort of angling. And it's been found that some of these fall fish middens, they would smoke these fall fish and store them, and they'd be buried. And several of these have been excavated in the Upper Potomac River basin, right, in the terrace, the floodplain, and those were intact. So either the tribes that harvested those fish, either they didn't need them, which is interesting. Maybe the deer were plentiful enough that year they didn't need them, or the tribes left because it wasn't suitable climate. You know, we think about climate change as some sort of theoretical abstraction. No, in this particular place where we live right now, climate change has shifted where people live. This is the thing about this deep sense of history. I think it's so important. You know, we think we're the first ones to, you know, experience change. No, we have to zoom way out, and we realize that the places we are, the rock that we touched, that piece of limestone behind Shepherd Village is hundreds of millions of years old. I mean, that gives us a deep sense for hopefully appreciation.
Charlotte wrote a question, and I'm going to add something to the question. So she typed, I don't know how Shepherdstown treats Potomac water to make it drinkable. Can you explain? And what does it mean to say the town runs a backup? How would that work? I would add the question, why would it be that the Potomac's no longer usable? And how does DC metro area as a whole get backup water? Is it through aquifers and things? So I guess it's just a whole question about the treatment of the water, and when does it become not usable, and what is the alternatives?
So I'm not an expert in water treatment. Maybe others on the line here have more direct experience than I do on this. But I can say that the town of Shepherdstown recently has upgraded its water treatment facility to improve our treatment of water. So on two levels. One is on the incoming side, and the other is on the outgoing side, because we're putting a pipe into that river as well, and we're sending all of our municipal waste downstream. Now, one of the disturbing things about drinking river water, quite frankly, is you can get on Google Earth and look at this yourself. Go to Luke, Maryland. Go to Google Earth and search for Luke, Maryland. What you'll see is a discharge system from their municipal waste that feeds right into the water that we're drinking. And it's not just there, it's all sorts of communities, all upstream, but it's most obvious there. I mean, in a nutshell, the idea is that, you set up different treatment levels, and so there's a primary treatment, secondary, tertiary treatment. Basically, the idea is the primary, you kind of screen out the big chunks, and then the secondary and tertiary are more chemical in nature. And so, I can't really go into a lot of details because I'm not familiar with the details. But I know that with the investments that the town made has recently really helped us be responsible stewards of the river too, because DC lives downstream. The Potomac River has gotten a lot of attention, obviously, because this is the source, the primary source of drinking water for Washington DC. And you can think about the national security implications of that. And I'd like to also think about just the cultural importance of that too. Urban fishing is a big deal in DC, and fisheries, it's some people treated it, it's kind of fun angling, and you're also like connecting with nature, and I really appreciate that. but it's also survival for some people. And I think it'll be increasingly that in the future. Urban fisheries are an important part. Now, this is where the contaminants piece really comes in, because it happens to be that the fish that are harvested, common carp, for example, a very popular urban fish, it also is one of the species that accumulates the highest toxicity load because of its place in the environment. So that's a concern. But you know, in this region, you know, the river water is a very different thing than the well water, and that's, you know, in terms of like how hard, you know, water hardness. If you don't have a water softener on well water in Jefferson County, it's going to be like crystallized calcium. You have a glass, you know, you dump it out, it's going to be caked in white. That's just the calcium showing up again, which makes our place here kind of unique. And it also makes us, in a unique way, kind of resilient to climate change. And let me explain why. As you take if you run water through a bunch of cold rocks, fractured limestone, the water coming out is going to be a lot colder than the water going in. So even though rainfall is going to increase in temperature, the temperature of rainfall will increase. And also, by the way, the severity of those events will increase. The fact that we are sitting on top of a sponge right now, we're sitting on top of like a limestone sponge. That's going to protect us in some ways, because what comes out the other side of that sponge is going to be buffered, and it's going to be sort of filtered in a way by all that rock contact. That's a lot of surface area under there. And so I think that's kind of, you know, optimistically a kind of good news story from a climate change perspective for our place.
Charlotte, did you want to follow up with, did you have questions about the answer there, Charlotte? And then I've got one from Jill. No, you're good. Okay. All right. And then so the backup supply for the metro region, I guess, gets their water from near Great Falls or whatever.
I'm not sure what their backup supply is, honestly. I don't know. I know that the river main stem is the primary.
Mm-hmm. So Jill said she's interested in the history of fishing. There's a newspaper article in the 1860s, Hagerstown paper, explaining, I guess she's been reading some old papers, explaining it was illegal to fish in the Antietam by beating the water. What kind of fish would be caught that way?
Well, it's amazing. You know, this is so weird, but in Virginia right now, if you go and Google up the state regulations, the fishing regulations in the state of Virginia and West Virginia for that matter, harvesting, I don't even know what they call it, but basically it's by stunning these fish. So, you know, one of the interesting physiological things about fish is they're very sensitive to pressures in the water. So the water is much more dense than air. And so they've evolved. In fact, our great ancestors evolved the ability to be sensitive to pressure, to changes in pressure. And we can feel it on our skin, but fish have a unique feature called a lateral line, where there's basically a bunch of holes that are poked through the side of a fish. And each one of those holes has a couple of hairs in it. And as the water changes, the hairs bend, that sends a signal to the body. It's an electrical current, and they understand they're very sensitive to changes in water pressure. Basically, that biology of the lateral line basically gives them a sensitivity to those kinds of changes that, you know, make them more sensitive than other species. So so I'm off track. Now, what was the question?
The beating to catch fish, illegal to fish by beating the water.
So this is where you can actually catch fish by overstimulating their lateral line. If you just send a pulse through. I mean, the way that we do our sort of technical sampling, et cetera, is to use electricity. Kind of does the same thing. So what kind of fish? Basically all kinds. And in fact, it's counterintuitive. Like you think that, you know, big fish might be more resilient to this kind of thing. Big fish are actually more sensitive to this kind of thing because they've just got more area to be intercepted. So here's how it would work, in Virginia. You take, and I'm serious, people actually apparently do this. It's in the regs, the fishing regs. You take a metal bat and you go and smack a rock that's sticking up out of the stream, and fish will float out. It's because you've stunned them. You've overwhelmed their. And I'm guessing that's might be. I don't encourage that. I'd rather, look, I grew up on the whole, a river runs through it, the fly fishing kind of situation. I did my master's work out in the University of Montana, and I did my PhD work at Virginia Tech. So I've seen, different approaches to fishing, and I don't recommend beating, but it is a way to harvest fish. And, what we typically do when we're doing our formal sampling is to use electricity. So we have a little backpack system that generates an electric current. We have an anode and a cathode. It stuns fish. It doesn't kill them. But as we move upstream, you kind of send an electric current. It overloads their lateral line. And they roll over. You got to snap them up with a dip net really quickly, because they're gonna snap back in a second. And then you can put them in a bucket, count them, measure, and then release. But it's the same principle. Ultimately, you're dealing with the physiology of these fish to
It's good.
grab them.
It's good to remember, if we run out of food and we need food, now I know some ideas on how to get fish. What are the things we might, and by the way, it's okay if we're running late from our perspective. This is totally appropriate if people have questions. It's great to have you here. So as long as you're good, we'll keep reading them. Just no more than midnight. No, I'm just kidding. What are the things we might be doing that would inadvertently harm the river and fish? Leah asked.
Well, there's a lot to that. I really, I think we've got a handle on the pipes. What we need to get a better handle on is the stuff that doesn't have pipes. And by that, I mean, it's not perfect, right? If you have a pipe running into a river, this was like the 60s and 70s, like stop the junk coming out of the pipes, right? And the Clean Water Act has done a good job at that. But here's the frontier. All of the landscape that doesn't have a pipe pouring out toxicity, it still affects things. And this is called non-point source pollution. This is the real frontier. And so what this means, and this is tough, but what this means is smart growth. It means comprehensive management plans. It means county zoning and planning. It means appointing county commissioners who will be appointing good county planners. It means all of that. And this is where the real work is. And I kind of see this as, the lifelong challenge of trying to be thoughtful in how we grow and develop. I tell you this, though, the word development, we can't let that word go. That is, people, you say the word development, people think pavement or houses or pavement, et cetera. That's not the development should mean conservation. Greenways. I look at the protection that happened near Shepherd Village on the Potomac with respect to the battlefields, Trough Road, and all of the sort of, that's development, right? We can't let that word go. And so, to county planners and zoning officers, I respect that work. That is where the attention needs to be. Those decisions at the county level are the ones that matter for the river, and they matter in the context of non-points, not just the pipes.
Okay. Rob asks, I know there are other rivers that have a problem with invasive fish. How about the Potomac River?
Yeah. Great question. So big picture, there's like maybe 100 species of fish that you could find in the Potomac River above Great Falls. But of those, only about half are native. Actually, less than half, honestly, which is kind of crazy, right? Less than half. So what makes the Potomac kind of unique from that perspective is not that we have tons and tons of different fish species. For example, if you go to the Tennessee River, near Knoxville, Tennessee, you could see hundreds and hundreds, you could see 3 times the number of fish species than you do in the Potomac. The reason for that is Great Falls. Great Falls provided a historic barrier for millions of years. Most fish can't get up it. American eel are an exception, right? They're very cool, very cool exception. But most fish can't ascend that. So it's created isolation. And that's why we have species that you'll find here, but nowhere else. Okay, that's what endemism means, or here, but nowhere else on the planet. It's unique. But there are some concerns. Let me highlight a couple real quick. Fisheries managers in Maryland DNR that I work with all the time, flathead catfish is one of the big concerns for them. Flathead catfish are moving upstream. Now, you'll see this if you get on the C&O Canal, there'll be warning signs like, anglers do not release flathead catfish. You can tell flathead catfish because they're sort of a mottled brown and green color. They're a very flat head, right? And they're voracious fish eaters. And it's thought that they could really diminish the other fish populations that we care about and that are economically and culturally important, such as smallmouth bass. The work we've done so far really does not suggest that it's the introduced species that's hurting smallmouth bass. I think that's still an open question. I'm open to new data on this, of course, but at this point, I think the balance of evidence shows that it's environmental change, flow regime, maybe temperature, but certainly flow that's driving down smallmouth bass numbers, not so much the introduced species by comparison. But let's face it, all of the very popular but all the popular recreational fisheries in the Potomac are introduced. And, that's not inherently good or bad. It's just the truth. Walleye, muskie, smallmouth bass, channel catfish, they're all introduced. In fact, when George Washington and crew showed up here, back in the day, and they started sampling, one of their first observations was the Potomac River is devoid of meaningful fish. And, they thought of it as a big black hole, like nothing's there. It's all just open for just dumping whatever in there. And that was perceived. And that's why the smallmouth bass were introduced in 1854. It's thought as we're going to benefit this place by introducing species. And sure, there is some benefit for that. But I think we've come a long way from thinking that more is always better. In fact, what makes us unique is that, we have species here, but nowhere else on the planet. That makes us kind of more unique than having a whole huge list of different species. Anyway, the point is, just to wrap it up, the idea of introduced fishes that are super important. I mean, walleye, muskie, smallmouth, channel cats, they're super important, but they're all introduced. And so the new ones may or may not be troublesome. We've heard a lot also about Asian snakehead down in the lower Chesapeake Bay, and that generated a lot of panic. But it turns out that is not wreaking as much havoc as people suspected. So that's kind of another part of the ecosystem, and that's going to be there too moving forward.
Leah had a follow-up, but what are our political allies for this kind of development? I think that was regarding what we might be doing to inadvertently harm the river question. So political allies.
Yeah, that's a question for you. All would know more about that than I would, and I, as like a research biologist, it's not really my space to go into that. But
okay.
I will say that I think we have some major challenges there, and also I'm more and more motivated to work at the county level than I have ever been, and we have some opportunities there coming up here in November.
Do you like to eat fish?
Yeah.
What's your favorite fish? Quick question.
Well, honestly, I'm spoiled. I get people mail me smoked salmon from Washington State. So that's like, can't do any better than that. And honestly, we're blessed by our local sushi shop. They source out of DC, which is a great market too. But I don't eat. I fish for smallmouth bass. I fish for brook trout. Brook trout I will eat. Smallmouth bass I won't.
Okay.
So yeah.
So Todd has a question he's going to ask.
Sure.
Well, these days one hears various terms related to the environment. One of them is environmental sustainability. Another is regenerative agriculture. There's the concept of reciprocal relationship to the environment. How do you sort of evaluate these terms with respect to the fish and sustaining the fish, because sustainability has to do with living within the Earth's natural cycles, but perhaps some of the others might involve a far more mm, aggressive type of interaction?
Yeah, good question, Todd. I mean, one of the things that's I've I've gained from this line of study is how we are all connected. So the water cycle is like the case in point. Water goes up, water comes down. It's all a big circle, you know. You it's interesting that every drop of water has been cycled through biological organisms multiple times. Now, some water is created. I mean, electricity, like lightning, creates water, but most of this water is not created. It's recycled. So I think a river perspective highlights the fact that we are part of a larger circle of things. We're not separate from it. We're a part of it. So, and we're also, by the way, made of water, right? Of course. So to me, that's the starting point. You know, the terms sustainability, you know, I'm not, I don't feel strongly about some of those definitions, except to say that we can see very clearly that, you know, look, from a deep evolutionary perspective, extinctions happen. I mean, you know, this is something I want to see sustainability. For one thing, I think a problem with that term is that I don't strive to be sustainable. I just strive to, I strive to thrive. I don't, you know, like someone asks you like, how's your life doing? Are you happy? Oh, no, I'm sustainable. You know, it seems like, I mean, it's better than tanking, but you know what I'm saying? Like, we want to do more than sustain. We want to thrive, and that's something that I think you can get from the rivers. I mean, one of the things I've had the opportunity to do, apart from just the fisheries part, when you get people onto the river together, something interesting happens. The rest of the world kind of fades. You guys know this. The rest of the world kind of fades away, and you're on the river together. You're coming together, you know, you're moving through space together, moving together, and there's a unique kind of bonding that happens there. I've had the privilege of spending 2 weeks on the Yukon River in Alaska, in backcountry wilderness on the Brooks Range, and spending time, you know, days and days on the South Branch of the Potomac with people on the Potomac main stem. I feel like these are the times that have enriched me, and I feel like that brings us together. And very importantly, especially for right now, people operate in the world as though we are red or blue, right or left. We have to abandon I'm preaching to the choir. We have to abandon those concepts, because we are all drinking from the same cup. We are all made of the same material, and you see it and feel it when you are on the water with people. And also something really radical, I think, that I've appreciated from my experience in this. Fisheries matter, right? You need to be able to go to, I mean, for example, I've had the privilege of going to small towns across West Virginia, and you can connect with people. And I've grown up in West Virginia. I'm a 10th generation West Virginian. My dad's south side of the state, my mom north side of the state. And I've done research on mountaintop mining and some controversial stuff in that context. And when I go to talk to people and meeting people, the rivers bring us together. You know, fishing is a cultural touchstone. It's fundamental to how we see nature. And I love the fact that you have Trout Unlimited on one hand, and you have Bassmasters on the other hand. And we're all talking about kind of the same resource, which I love that. Now, I've just been thinking about that more in the context of where I think we are as a nation. And honestly, in Jefferson County, how we seem to be getting further and further apart. We need to be coming further and further together. And these kind of places and these experiences have that opportunity. For example, you know, Facebook, the Bassmasters, I'm talking to them, the Trout Unlimited anglers up in the South Branch, I'm talking to them. So I think there's a big cultural opportunity here that I don't want to undersell. I think that's a highlight for me. But you know, your good question about what do rivers mean for how we think about sustainability? I think the big answer is it gives us a sense of our deep time, deep place, and our connection to things that allows us to have some humility. So we go into planning in a sense of respecting what we have right now, as opposed to disregarding it as for free. We've always treated rivers as though they're for free. We've treated them as sewage ditches. The water comes and the water goes. It gives us all we want, and it allows us to dump our trash in it. And I think that's, in a way, sort of emblematic of how we have lived as a society, unfortunately. And it's also an opportunity for us to kind of be refreshed and rejuvenated when we think about cleaning these places up. We are on a right trajectory. As Phil asked earlier, I mean, our contaminant loads on the river are actually, we're improving in many ways, and we need to really celebrate that.
Yeah, well, I think that's a great way to end today. I connected with the river by falling in it last month from my kayak. That was a unfortunate read. But other than that, I did enjoy it. I want to thank you, especially Than, for taking the time, and it's been wonderful. And thank you, everyone. You can unmute and give appreciation. That'd be wonderful. But we
Thank
really
you so much.
Yeah, very interesting. Thank you.
Thank you.
And if you have any
Super.
follow-ups, reach out to me. You can Google me up at USGS. And seriously, if you want to follow up, please do via email. I appreciate that.
Thanks.
So cool.
Thank you.
Thank you.
Yes.
Thank
you all.
you. Thanks so much.
Thank you. Thank you.
Bye, Than.
Well.